So next topic in the vector field and scalar field, we have there are two very important terms where we have divergence and curl. Okay, so this one is a continuation from the gradient that we have seen before. We have discussed on how can we obtain the gradient of the scalar field. Okay, so now by using that the triangle upside down, which is we call that as a nabla or grad, okay, the gradient. So we can use it to obtain the divergence and curl. Okay, so divergence. So the short of sometimes in the instruction or in the question they will give you a full divergence. But sometimes they just use short form div, div. So divergence of the vector field. Okay, for divergent, we should have the divergence of vector field. But for gradient, so the gradient of scalar field. But divergence should be the divergence of vector field. So that's why we have the vector f. This one is a vector. Okay, so what is actually divergence? So what is the physical meaning of divergence? So this the value, so they will give you once you done the calculation, so you will get a value. So this value is a measure for how the vector field spread out or diverge from a point. Okay, suppose that the vector field f is the velocity field. So velocity, vector, something, a vector function. So that is a velocity field of a flowing fluid. So this is something about the velocity of fluid, the fluid flow. So then the div of f, or the divergence of the vector field f, represent the net rate of change, the rate of change of the mass of the fluid flowing from the point per unit volume. So the divergence is a measure of the tendency of fluid to diverge from a point. Okay, so that is the physical explanation. What is the divergence mean? Okay, so when you calculate that, so there are some values. So it can be positive, it can be negative, then it also can be zero. So what is the physical meaning of this? So if your divergence is positive, so as you can see here, so this one is the flow, the fluid of the flow of the fluid. Okay, so if you got the divergence positive, so it says that this point is a source point. So P here, point P. So we know that it represent. It says that so we have the P here is becomes a source point. However, if we obtain that divergence is negative, so we can see that this point is a source. Okay, sorry, this one is a source. So if it is positive, so it is we call this point as a source. But if it is negative, so that point is a sink. Okay, and if the divergence is zero, so meaning that the fluid is said to be incompressible. So if this is happens, so this vector field f is called a solenoid vector. Okay, if you maybe in future you learn about the something fluid dynamic. So normally so you have to use the in order for you to simplify the calculation, so you need to assume that the fluid flow is incompressible. Sorry. So how can you, just to simplify your calculation, so we always normally assume that the fluid that we are investigating is said to be incompressible. That one is normally you will see that in PDE when you solve a problem which related to fluid flow. Okay, so as I mentioned just now, we have a source, we have a sink, and incompressible. Okay, so how about the calculation to obtain the divergence of a vector field? So the since so the formula here, how can you obtain the divergence of the vector field F? So the formula is gradient dot. Remember, for vector field or a vector function, so you cannot just multiply the gradient and the F, so it cannot be happen because this is a vector. So the vector, when you do a multiplication, it can be whether dot product or cross product. So for divergent, you have to use a dot product. So which means that the answer here should be a constant or an expression. Okay. So how can you have the what happen if you put the gradient to the vector field? So as we know that the gradient here is a vector operator, and we dot with all the components for the in the vector field F. So meaning that it just like you do the multiplication. So del x of F1 plus del y of F2 plus del z of F3, which means this one. So meaning that you have to take each component here, then you have to differentiate respect to x for component x, and F2 you have to differentiate respect to y for component y, and F3 for component z you have to differentiate respect to z. Then your answer here is an expression, and then maybe they will give you a point. So you want to investigate the divergence at that specific point, then you can have the value when you after you substitute the value of x, y, and z. Okay, now look at the example 9. Calculate the divergence of the vector field given here. So your vector field is x and y, only 2D. So when you obtain the divergence of the vector field, so you have so you have the grad dot f. So you have just like del x, so that is for the component gradient. Okay, the gradient. So del y dot with the x and y. So meaning that here what you have to do is this one you should multiply by this plus this one and multiply by this, so it end up to be del x plus del y over del y. So we got 1 plus 1 and you got 2. So in this case your divergence is positive, so meaning that the point, for any point there, so that point is always become source point. Okay, so how can you know that? So if you got the positive, so the point fluid arrive through a source point. Okay, so meaning that the fluid flow is always arrive through a source point, because this one it's happened for any x and y. Okay, but sometimes it's depend on the point that we have. Okay, they will give you I mean that when you do the partial derivative, so you sometimes you can have an expression, so you have to substitute the value, but this one it looks like for any x and y, and the point, all the points become a source point. Okay. Okay, let's say I give you another example regarding the divergence. So let's say example 19a. Okay, so find div f at the point of 2 minus 1 1. if f is let's say, so I will give in IGK form 3x plus y I plus g plus y minus 2z. Okay. Okay, so to answer this, we know that divergent of f is grad dot f, which means that so let's say this one I give a name f1, and this one is f2, and this one is f3. So we have del f1 del x plus del f capital F2 del y plus del f3 del z. So how can we get that? So from the gradient we know that we have del x, del y, del z, and then dot with the, okay, I just give a f1, f2 and f3. So when you apply the dot product, so it looks like we have the del x of f1, which is this one, plus del y of f2, which is this one, and the third term del z of f3. So what then what you can see here, that each term, each component here need to be differentiated. This one respect to x, this one respect to y, and this one respect to z. So then you will get, okay, f1 is 3x plus y. So you differentiate the del x of 3x plus y, and you will get 3, right? 3 plus, then del y of x minus y, then you will get minus 1, plus del z of y minus 2z will give you negative 2. So you have 3 minus 1 minus 2. So you will get 0. So meaning that your divergence is 0. So you can see that the given vector field is a solenoid which is incompressible, right? So since the answer is already 0 without putting any value of x, y, and z as given here, then we can say that but we can have the explanation here. Therefore the divergence of f is equal to 0 everywhere, right? Everywhere for any x, y, and z, including the point given, which is at 2 minus 1. Okay. Okay, here I give you one example. This one is the last year final exam. So here we have the question which are related to the topic of divergence. So for example, here look at this one. Given a solenoid vector incompressible. So what can you understand with that? Solenoid vector incompressible. So we know that divergence is equal to 0, right? The grad dot f. So is given by f. And here there are the expression in terms of beta, alpha. So then using that understanding of what is the meaning of solenoid, so we want to find the value of alpha and beta. So in this case, if you've forgotten about the property of the divergence, and that one has relate with the solenoid vector, so you have no idea how to solve this. But you can see here, if you know that, then it's easy for you to do that. I mean, to answer this question. So what you have to do is, you just, since we know that from the information provided, given a solenoid vector, which means that how can you have a solenoid vector? So you can have a solenoid vector, vector, which means that this one has to do with the grad dot f equal to 0. So now what you have to do is you have to find the gradient of the vector field f. So the gradient f, which means that you have del f1 del x plus del f2 del y plus del f3 del z equal to 0. So which means that you have to take each component here. So here you have to differentiate. So the first component is 2xz. So 2xz sine of alpha yz. Okay, and you have to find that. So differentiate with respect to x. So alpha yz, so no x here, meaning that, so this one just 2z. Okay, so you can see the x is outside the sign, which means that you have to just differentiate the 2x, so you just get 2. So 2 and the rest are constant, so 2z sine of alpha yz. Okay, and then we go to the second part, del y of f2. So your f2 here is beta yz plus cos of 2yz. So when you differentiate that with respect to y, so you have two terms here. So the first term you have to differentiate with respect to y, then we give you beta z. So differentiate. Now you can see the y inside the cos, then you have to apply the chain rule. So differentiate the outer function, you got minus sine of 2yz and multiplied by the derivatives of the inner with respect to y, then it will give you 2z. Okay, and then the third one, differentiate del z of the third component. So you have negative 3 over 2 z square. Then this will give you negative 2 and then 3 over 2 z. Then you have minus 3 z. So you have to total them up. So you can have so 2z sine alpha yz plus beta z minus sine, so minus 2z sine 2yz minus 3z equal to 0. So meaning that now how can we obtain? We only want to get the alpha and the beta, and we should understand that this one is all the term here when you total up and the answer is 0. So it looks like you can see the pattern here, right? The pattern of this one has a similar pattern as this, and then beta z and minus 3z, if you total them, it should be 0. So and because of we want to make sure that this one to be 0 at the end, so this one we assume this and this should be the same, right? So that the answer, when they total them, when we total them up, so the answer is 0. So you can say that based on this and this, then we can say that beta is beta is 3. So meaning that if beta is 3z and you have minus 3z, and you will get 0. Okay, so that is the reason why we say that beta is 3. Okay, and similarly, now we look at for this one and this one. So you have the same, right? 2z sine and 2z sine. Now you have negative, which means that we assume that these two terms, they are the same. So if we want to make them the same, then we have to assume that now you can see this one 2, and we have alpha. So we can say that alpha is 2, or you just say alpha is 2. So then when we substitute beta 3 and this one 0, and when we substitute alpha 2 and this one 0, so that's why the answer is 0. Okay, so that is for this particular question. So it looks like simple if you know this. So this is a bit tricky if you do not know what is physical meaning, what is the meaning of solenoid vector. But once you know, it is not so complicated. That's why the mark is just 3 marks here. Okay. So also we have, you can see that the question 3c, you are given the vector r, x, y, z, and we are given r, where r is in terms of x, y, z, is given by the square root of x squared plus y squared plus z squared. So this one is actually the formula of the magnitude of vector r. So from this information, we have to obtain these two expressions. So how can we do that? Okay. I want to show how can you, from the left you got the right. Okay, so what is the information that we have? So now the first question, we have to show that the gradient of the r is in scalar form, which is this one, to the power of n. So this just like multiply, because r here is a scalar function. Now you should have n, and then rn minus 2 multiplied by the vector of r. So how can you got the right side? So it looks like, and the idea is you have to use the r formula. R is the square root of x squared plus y squared plus z squared. Okay, so now how can you have the rn? So r to the power of n, so you have the x squared plus y squared plus z squared, and then you have n over 2. So now you have to find the gradient. Okay, so this one is a scalar field. Okay, remember last time, if you have the grade f, then what is the answer? Then this one is supposed to be vector. Okay, vector. So you will have a vector, right? You will have a vector, and where the component is fx, fy, fz. Okay, so now for you to obtain the gradient of rn, and where your rn is this one, so meaning that you have to differentiate, to assume that this one just like a function, so you have to differentiate this scalar function with respect to x, with respect to y, and with respect to z. So that is the thing that we want to do. Okay, so here so let's say this one is called as f. So fx, you have to differentiate differentiate the rn with respect to x. Okay, which means that del x of r n. So you have to differentiate respect to x. So this one n, where is the x? So the x is inside this function. So you have to differentiate the outer function. So you have n over 2 x squared plus y squared plus z squared n over 2 minus 1, and multiplied by the derivatives of the inner respect to x. So this one becomes to x and the rest are 0. So you have 2x. So when we simplify that, so you will have n x, and then x squared plus y squared plus z squared n minus 2 over 2. Okay, and then keep going for the fy. So del y of the Rn. So now differentiate the outer function here. You have n over 2 x squared plus y squared plus z squared n over 2 minus 1, and then you have 2y. So when you simplify, so you have ny x squared plus y squared plus z squared n minus 2 over 2. And then similarly, the fz, so del z of Rn. So then you will have n over 2 x squared y squared z squared n over 2 minus 1 2z. And when you simplify, you will get nz x squared y squared z squared n minus 2 over 2. Okay, so that is the vector that you will get. Okay, so based on your result here, now we can see that, so this one is actually n x, and we know that actually r here is x squared plus y squared plus z squared to the power of 1 over 2. So you can see there is a 1 over 2 here, 1 over 2. So you can rewrite that to be the r, okay, the r n minus 2. And this one also the same. We have ny r n minus 2. And this one nz r n minus 2. Okay. And then if you rewrite all these components into this vector form, so the gradient of the Rn now becomes, okay, so the gradient of the scalar field Rn is fx, fy, fz, and then we plug in all the component, this one, and this one, into a vector form. So we have nx r n minus 2, ny r n minus 2, nz r n minus 2. So then you can see here there is n r everywhere, right? Then we can factorize. So n r, n minus 2, then we just have x, y, and z. So n r, n minus 2 is a scalar, is constant, and x, y, z is a vector, r, vector r. So we have this. So then you see that it is shown. So now we manage to show how can from the left we got the right side. So that is the procedure, okay, to get this one. And similarly for the second one, so for the second one, by using the information provided, now we have the cross product. So meaning that you have to find out the Rn of R first. Okay, so what is, this is for the second question. So the Rn of vector R. So Rn of vector R, so you have Rn of x, y, and z. So here you have Rn x, Rn y, Rn z. So you have to find the cross product. Then you have to show that the cross product is equal to 0. Okay, so we know that Rn, R is the square root of x squared plus y squared plus z squared. So you can have x squared plus y squared plus z squared, it's the power of 1 over 2. So that's why we have n over 2 here. Okay, similarly for the y component and z component. So now we want to find the cross product. Okay, the cross product of this one. So you have, so the cross product of Rn of vector R. So you have I, T, okay, so del x, del y, del z. So the component here is x squared plus y squared plus z squared and over 2 and x and y. So y squared plus y squared plus z squared to the power of n over 2, and then z, x squared plus y squared plus z squared n over 2. Okay. So then you have to I, so del x of x squared plus y squared plus z squared to the power of n over 2. Okay, so now we want to get the result. So to get the component x, you have to cross this and this. So del y, so del y of the z of x squared plus y squared plus z squared n over 2 minus del z of the y x squared plus y squared plus z squared to the power of n over 2. So that is for x component. And then for y component, you need to cross this and this. Okay, so for the del z, okay, so del z of x, then x squared plus y squared plus z squared to the power of n over 2 minus del x of, you have z x square plus y square plus z square n over 2. And then for component k, so you have to cross this. So you have del x of y, x square plus y square plus z square n over 2 minus del y of x square plus y square plus z square n over 2. Okay. So next, so you have to okay, firstly, I try to find out this one. So this will give you okay, y is inside here. So you just differentiate the outer function. So you have okay. So for del y of z x squared plus y squared plus z squared n over 2. So the answer is n over 2 z x squared plus y squared plus z squared is n over 2 minus 1 and then 2y. So then you will get nzy of x squared plus y squared plus z squared n minus 2 over 2. Okay, and then for this one, so you have del z of y x squared plus y squared plus z squared n over 2. Then this will give you n over 2 y squared plus y squared z squared n over 2 minus 1 2z. So you will get n zy x squared plus y squared plus z squared and minus 2 over 2. So you can see that for the first term, you will get the similar expression. So then for the first term, then we can obtain that. So I'll just show you the first one. So for the first component, you obtain that minus del z of y x squared plus y squared plus z squared n over 2 is 0 because you will obtain the similar expression. So now you have to look at the second component and the third component, and I'm sure that your final answer here for this also you will get 0, and this one because they will have the similar expression. Similarly for the third component also you will get the similar expression. So when you total up, and the answer also 0, so then you can show that you will get the 0 vector. Okay, so that is for this answer. So I'm not going to complete that, so you have to just continue the step. Okay,